So, where we left off at part 2 of module 1, we took geometry that we drew in Rhino, and then we turned it into a bunch of points and a bunch of curves that Karamba could use. And now something that's really important in the first step should be is to flatten the data. What this does is it sort of cleans up the data tree that Grasshopper got. So I right-clicked on P and then clicked on flatten, and I'm going to do the same to the curves. Right-click and flatten. So what happens is now we just have one list of curves and one list of points, so there won't be any confusion. Next up, we're going to turn those lines into beams. So you're going to type in line to beam, which is a Karamba command. And you put in those points, those lines, and now you've got something that Karamba can use. Next up, we're going to assemble the model. And this is where you sort of put in all the information that Karamba is going to use. So I put in the points again, the elements, and now I need to define supports and loads. And the reason for that is currently I put in a bunch of beams, but there's nothing happening to them. So when I do an analyze Karamba, which is when it starts to look at everything you've done, it can't really do anything. It has this red color because nothing is being done. So I need to decide where the supports are. And the way I do that, supports and the loads, I'm going to choose point loads that I can decide and load at different points, connect to the load parameter, and then under ensemble support, I'm going to apply some supports. I'm just going to go ahead and put the supports resisting in X, Y, and Z direction, and also rotation in the X, Y, and Z. So they're essentially fixed supports. And now what's important is I need to decide where those are occurring. And this is where the position index parameter is really important. When you put in those points, there's a really useful command called point list. I can take these points, and another useful thing, you double click and type in a number, and you'll end up with a number slider. And give that the size. So now I've got all the points labeled based on how Grasshopper sees this geometry. The labeling doesn't always make sense, but it's really useful to know this so that I can call out those points and say loads are happening at points 0, 1, 2, 3, 4, and 5, and that the supports are 6, 7, 8, and 9. So double click and double slash will give you a panel. I'm going to turn this into multi-line data. And this is for the loads, so it's going to be 0, 1, 2, 3, 4, 5. And this is just labels that Grasshopper is giving me for each of those points. I put it at the position index. And then for the supports, type in a double slash once again to get a panel. Turn it into multi-line data. And label 6, 7, 8, 9. And that's where the supports are. And now I need to apply what kind of force. So I'm going to make it a z force. So type in z to get a z vector. And then double slash -1, 1 force unit. So that's everything. So now Karamba is happy, it's analyzing. And now to view it, I'm going to type in model view. And this is where it gives you a lot of choices on what you're seeing. There's deformation scale, which doesn't change the deformation, but it changes how much it looks like. So when I connect model to model, all of a sudden you see what it's doing to the structure. I'm going to change the deformation scale. It'll tell me roughly. I can choose things like show me the load values of one, different things like that. And then finally, I'm going to do beam view. And this is where I can see the beam specifically. And you see that it gave them some thickness, and it'll tell you information like displacement, utilization, axial stress, all those kinds of things. So that's the simplest way that Karamba can be used. Right? Good luck. And for sitting through all of this, here's a baby elephant. Thanks. Bye.